I thought I'll solve a personal problem that requires memory. I continuously use voice assistants like Alexa, but these are kinda dumb because they don't have the relevant memory and context. Thanks to Cogni, this was super simple and easy to implement. Let me show you how this works. So, introducing Project Naira. This is a fully open source DIY voice assistant. It's built using Raspberry Pi, display and a mic. And this is one of my best voice assistants because unlike this has personal memory using Cogni and it's sort of like my second brain right now. And the wake word for this is Alexa, just tell me why Cogni should hire me right now.
Cogni should hire you because you bring senior level expertise in production grade Solana protocol engineering, combined with deep wallet and custody infrastructure experience. Your proven ownership of high impact, cost saving financial systems and AI automated pipelines makes you a uniquely versatile engineer ready to build cutting edge, reliable AI memory solutions. Want me to help?
Yeah, talk more about my AI experience and also draft a resume specially tailored made to them and mail it using my Hermes agent and send this task to my Hermes agent to do this work.
I've queued tasks to draft your Cogni tailored resume emphasizing your AI and blockchain expertise. Then email it to Cogni's hiring team using your Hermes agent. You'll hear from me once they're done, or if you want to add anything else in the meantime.
Okay, so this is the rough architecture diagram of the system, which is actually quite simple, but there's a trick to it. So the user voice is first detected using a wake word detection. This is running locally on the Raspberry Pi. So when I say something like Alexa, this triggers the entire pipeline. The pipeline is mainly composed of LiveKit and Pygame for the UI, but the LiveKit does the heavy lifting here. LiveKit has three components. I'm using the cascading models here: SST, LLM, and TTS. But I even tried voice-to-voice agent, voice-to-voice model. But the issue with that is that would do a tool call to the memory, and that didn't feel very real time when fetching the memory. So here I'm using a trick. So the trick here is I don't wait for the SST to complete. I start looking for the memory as soon as it has complete sentences and it starts making queries, recall queries to the Cogni cloud, which has the relevant graph memory. And then this keeps adding it into the relevant LLM context. So as you're speaking, we are doing the background recall calls and we are adding it to the LLM context. And the TTS output is given, which goes back to the voice. And once sufficient timeout is done, the session is ended. And when the session is ended, another interesting thing happens is we update the memories in the Cogni cloud, so that next time we come, our AI is smarter now. So we update the new memories and we forget the irrelevant ones, and so that we optimize the graph. And thing is, the best part of this, since it's in the cloud, it is synced to all my AI coding tools. For example, Hermes, Claude Code, all these have fragmented context about me. And now, with this tool, it's like I can just integrate everything and everything works seamlessly. I don't have to give the same context for one tool, and this is a much more simpler solution. And I also have Hermes. The main reason I have Hermes here is because something, if a task is complex, the LLM used here might not have enough capabilities, because here we are trying to use a real-time LLM, so less reasoning here. So if the task is complex, it can simply push to my Hermes agent, which has all the connectors: Gmail, to-do list, calendar, and this has more compute as well. But this takes a lot of time, so this is an async task which my Hermes agent running again on the Raspberry Pi completes. And once the task is complete, it sends the data back to my LLM, which tells the user that the task is complete, and this is also shown on the display. So yeah, this is something really cool, and I think this is going to improve my personal productivity. So this is the architecture. This is like a broad overview, but I had to do multiple experiments in separate repositories and figure out what made the project feel real time, because that was the main goal. Thank you. Okay, so this is how the Cogni memory looks like.